Okay, now we get to use what we've learned in word problems, applications. So even though these are word problems, they're not too bad because everything relates to a right triangle. So that first step is you have to draw a picture. For these problems, there's always going to be a right triangle involved. So no matter what they describe in the problem, think of it as a right triangle and then label the parts they give you. It's kind of the part that takes the most thought. Then when you get your picture, you're going to label it with whatever they gave you and then put a variable for what it is that they want you to find. Which side is it that you're solving for? Then it's just a regular old identify the O, A, and H. Solve for the variable. Which trig function do you need? Do I need to multiply by the number? Divide by this? Do I need to use the Pythagorean theorem? Like everything you've learned up to this point gets used to solve these problems. Okay, let's try one. A ladder leans against a brick wall. The foot of the ladder is 6 feet from the wall. The ladder reaches a height of 15 feet on the wall. Find to the nearest degree the angle the ladder makes with the wall. So you can see the picture here that's been made for you. Drew a building. Then they drew the ladder, this tough looking guy riding on it. And then they connected it to make that right triangle right there. It said that the foot of the ladder is 6 feet from the wall. Well, here's the foot of the ladder. Here's the wall. So that one's got to be the 6 feet. It says the ladder reaches a height of 15 feet on the wall. So here's the end of the ladder. And where does it reach? Well, that's going to be your side right here. So you should see at this point a right triangle in which it says 6 feet, 15 feet. And then we have to talk about, well, what is it we're trying to find? Now they put an X up here for you to let you know that's what you're trying to find. But you need to be able to read these and know which one it's talking about if you're finding an angle. So it says to find the angle that the ladder makes with the wall. Now that's important because we've got two angles, this one right here, and of course that one right there. The only angle that's touching the wall is that one right there. So this has to be what we're solving for. So this guy actually touches the wall. Okay, this is what we're solving for. We're going to use a trig function. This is opposite. This one is adjacent. That means we are using tangent. So tangent of x equals opposite over adjacent, which is 6 over 15. Now, if you remember to solve for an angle, we've got to use that inverse guy on your calculator. You don't have to reduce this because you're just plugging it into a calculator. And then you hit equal, and you should get 21.8. It says to do to the nearest degree, so we're going to round that up, and we're going to say that x equals 22 degrees. Okay, this one we're going to have to draw our own picture, so you got to kind of picture what's happening. We got Ben and Emma flying a kite, okay? Emma can see that the kite string she's holding is making a 70-degree angle with the ground. I don't know how she knows that, but whatever. The kite is directly above Ben, who is standing 50 feet away. To the nearest foot, how many feet of string has Emma let out? Sorry. Okay, so this right here is what we're trying to find. Once we get our triangle label, we can figure out where that X goes. We got our angle here. We just need to figure out where it goes in that right triangle. And then we've also got this 50 feet away. So we've got a few numbers to figure out where they go, but we know it's going to be a right triangle. So here's Emma. She's holding the thing for it, and the kite's going out along there. There's my kite. Flying. Oh, we got the little tail with the little bow on it. I wonder if you guys have ever flown a kite. It's not a big thing anymore. Anyways, okay, and then over here is Ben. And it says that he is 50 feet away, and we want to find how how much it is that the string is. So let's make our right. Okay, so we need to figure out what numbers go where. So 70 degrees angle with the ground. So there's two angles that we've got here. We've got this one and this one. This is one that would be considered with the ground, so that's got to be our 70 degrees. Then it says the kite is directly above Ben, who's standing 50 feet away. That means that in between Emma and Ben, that's 50 feet. It says how much, we got to find how much string has Emma let out. Well, there's the string, so that's going to be what we find. All right, here's our right triangle, taking Ben and Emma out of the picture. Here was our 70 degrees. Here was 50, and this is what we don't know. All right, so labeling everything, this is the hypotenuse. This would be the opposite. This guy's going to be the adjacent. So we are dealing with a trig function that has the adjacent. We're trying to find the hypotenuse, which is cosine. Sorry, momentary lapse. Okay, let's plug in what we know. Cosine of the angle, which is 70 degrees, equals the adjacent over x, because I don't know what the hypotenuse is. Now to solve this one, you don't multiply by it. This time x is down in the denominator. So the trick to this is you just get to swap these guys. And the other form, like over here, if this had been cosine of 70 equals x over 50, then you multiply. So when x is in the top, you multiply. When x is in the bottom, you're going to divide. So x is going to equal the number divided by cosine of 70, which is about 17, it says 17.1, but it says the nearest foot, so it's going to be 17 feet. Okay, now angle of elevation, angle of depression. This is one of the most common uses of the right triangle. Angle of elevation, when I hear elevation, I think rise, right? Like going up. When I think of depression, I think of, going down. So angle of elevation is an angle that's measured from the ground up. So if you look at this triangle right here, there's two angles, this one right here and this one right here. This one has nothing to do with the ground. So this is your angle of elevation. And the best way to think of it is like when you look at something. You're looking straight ahead and you want to look up to something, you have to raise your eyes. And that becomes this angle right here. The angle of depression is very similar. This one's outside the triangle. This is for when you are looking at something, or sorry, you're looking straight and then you look down at whatever it is. That becomes your angle of depression. And that one's always outside. Very, very similar. Now, one of the cool relationships between angle of elevation and angle of depression is that this idea of angle of depression, right here, angle of depression, there's a geometry rule that says if two parallel lines are cut by another line, these two angles are equal. So angle of depression in a triangle equals the angle of elevation. So you can use that to your advantage depending on what angle you want to use inside the triangle, whichever one works best. Let's look at an example. Okay, find the angle of elevation of the sun when a 12-meter tall telephone pole casts an 18-meter shadow around to one decimal place. Okay, got to start with the picture. So here's my telephone pole, and then it casts its shadow onto the ground. Now, angle of elevation to the sun means we're trying to figure out, here's the sun over here. So I can get my colors to work. And the sun's shining down on the pole and it casts its shadow. So to complete our triangle, we're making this triangle right there. We've got a perpendicular, right? The flagpole, or sorry, the light pole and its shadow, that forms our right triangle right there. And now we just have to label it with what we know. So I'm going to try with you. Okay, I'm going to take the flagpole out so we don't have to really think about what that all means. Okay, a 12.5 meter tall telephone pole. 12.5 meters. Okay, here's the telephone pole. 12.5. 18-meter shadow, that means the shadow is 18. And we're trying to find the angle of elevation, which is from the ground up of the sun. Okay, let's label. This guy's going to be opposite. This guy is adjacent. Everybody knows that trig function. So tangent x equals opposite over adjacent, which is 12.5 over 18. Okay, inverse functions, inverse tangent of that number equals about 34.78, blah, blah, blah. One decimal place would be 34.8. And it's an angle, so it's degrees. This next example deals with an angle of depression. So it says a cliff is 80 feet above the sea. So we've got this cliff, right? From the cliff, the angle of depression to a boat is 35 degrees. So it means we've got this boat out here. And then from the cliff, okay, so from the cliff, the angle of depression to a boat is 35 degrees. So here's the cliff. Angle of depression means we're going down, looking at the boat. So this is our angle of depression, which is going to be 35 degrees. Now, if we think of this as one line and draw it out to the boat right here, we've made our right triangle. It says the cliff is 80 feet above the sea. Here's the cliff. So that's where our 80 goes. And then like I just told you, angle of depression and angle of elevation are related. Since these guys are opposite, this one also is 35 degrees. And then it says, how far is the boat from the base of the cliff? That's this guy. All right, here's our triangle. We've got this guy is 35. This guy is 80. We're trying to find x right here. All right, 80 is our opposite. X is our adjacent. The trig function we would use is tangent of 35 equals opposite over adjacent, which is 80 over x. Okay, tangent of 35 equals 80 over x. Now I told you when the x is in the bottom, you can actually